Hello everyone, today we're going to be taking a look at some Section 2 practice questions. My name's Matthew and I'm a second year dental student, and I hope that my experiences will help you to prepare for your BMAT. As you can see, for Section 2, Scientific Knowledge and Application, you have 30 minutes to answer all the questions. In this section there is 27 questions in total, which leaves just over 1 minute per question. As you can see, the breakdown consists of 7 questions for biology, chemistry, and for physics, and then 6 for maths. To start with, Section 2 questions format has, as I've said, 27 questions in total. There is 1 mark for every correct question, and there's no negative marking. This means that your total score will not be reduced for any wrong answers. This section, as I've said, is 30 minutes long, and that leaves over just 1 minute per question. This presentation aims to show you some example questions from the BMAT specimen paper, along with an explanation of each of the answers. For the questions, I'm going to give you just over 1 minute, which is similar amount of time that you'll get during the exam. If you just look at the bar along the top of the screen, you'll see it's counting down for that timer. I wish you luck with the following questions. So, the answer for question 1 is H. This is because process 1 is the removal of nitrogen gas from the air into the soil, and this is known as nitrogen fixation. You should also know that the release of nitrogen back into the air, which is process 2, is denitrification. Finally, the breakdown of nitrogen-rich dead plant material is decomposition or decay. The answer for question 2 is option C. We know that oxygen is required for aerobic respiration, which releases energy. We also know that it is used for the movement of substance, and that the energy released is used for active transport, which moves substances up the concentration gradient. The only answer that shows movement against the concentration gradient is option C. The correct answer for question 3 is the option F. This is because we know that the SAN pacemaker is found within the wall of the right atrium. From this, we can deduce that the only viable options are B and F. To whittle it down to decide the final answer, we must realise that the left side of the heart pumps oxygenated blood to the body and that the right pumps deoxygenated blood to the lungs. This means only F is the answer to satisfy that. The correct answer for question 4 is option C. As you can see, we've got a right angled triangle. You should know that the area of a triangle is a half times the base times the height. In this question, I've provided some working. We know that the height is given as 2 minus root 2. So in this case, the area would be, in brackets, 2 minus root 2 times by, in another pair of brackets, 4 plus root 2, and all of this is divided by 2. This then equals 8 minus 4 root 2 plus 2 root 2 minus root 2 times by root 2 all over 2. You should know that root 2 times root 2 equals 2, and that you can simplify the expression to 6 minus 2 root 2 over 2, which then equals 3 minus root 2. The correct answer for question 5 is option B. This is because, in this question, every single term inside the bracket has to be squared. To do this, I've provided some working, and I've started by simplifying each term separately. As you can see, 2 squared equals 4, x to the power 3 over 2 squared equals x to the power 3. The square root of z squared equals z, and y to the power 3 squared equals y to the power 6. After this, you've got to combine each simplified term, and overall the expression will become 4x cubed times y to the power 6 over z. The answer to question 6 is option E. To answer this, I sketched the graphs which are on the side of the screen now as working. You can see from this the 4 equations. So, the graph of y equals 3x minus 2 is a straight line, and that intersects the y-axis at 0 minus 2, and the gradient of the line is 3. The graph of y equals x plus 6 is also a straight line, and this intersects the y-axis at 0, 6, and has the gradient of 1. The graph of y equals x squared is a parabola which touches the x-axis at 0, 0. And the graph of y equals 1 minus x squared is exactly the same shape as y equals x squared, but it has been inverted and translated by 1 unit vertically. As you can see in the diagram, it is clear that y equals x plus 6 and y equals 1 minus x squared don't intersect. So that gives you your answer as being E. So, the answer to question 7 is option C. To work this out, we know that the mass of the two cars is the same, and this means that the kinetic energy is proportional to the speed squared. Therefore, as car Q has twice the speed of car P, it will have 4 times the amount of kinetic energy. Next, we know that gravitational potential energy is proportional to the change in height. As we know, when a car rises to 50 meters, it'll have twice the gravitational potential energy of the car that has only risen by 25 meters. This leaves the only option as C. The correct answer for question A is option A. To work this out, you must know that the terminal velocity means there is 0 acceleration, and this means there is 0 resultant forces acting. When travelling at terminal velocity, the force of air resistance on the parachutist will be equal and opposite to his weight. It must then be realised that they are travelling at high terminal velocity before opening the parachute, and when travelling at lower terminal velocity after opening the parachute. When opening the parachute, there is a rapid deceleration, which means that there is a moment where there must be a resultant upward force acting on the parachutist. During that instance, there must be air resistance which is much greater than the weight. This means the correct graph has to show the same air resistance force in the same direction throughout, other than during the moment of opening the parachute, when there must be a larger air resistance force against all in the same direction, and the only graph which shows this is A. So, the correct answer for question 9 is option B. To answer this, we need to think about the waves in air. We are told that they have a wavelength of 12 centimeters, which is the equivalent of 0.12 meters. We also know that the speed is 3.0 times 10 to the power 8 meters per second. So, using the calculation in the working which is given on screen, we can find that the frequency is 2.5 times 10 to the 9 Hertz. Now, to answer the question, we have to think about the microwaves passing through the plastic. We know that the plastic will slow the waves down by reducing the wavelength. So, we need to use calculations to find that in the plastic, the frequency is the same, but the wavelength is shorter. And we know that it's shorter than the 12 centimeters by a factor of 3/2. And this equals 8.0 centimeters. This means that the only option to satisfy this is option B. The correct answer for question 10 is option B. To answer this, first you must realise that the compound is ionically bonded. Now, none of the compounds A to F have an overall charge, so we can use the charges of the individual ions to find if they equal 0 in the compounds. We know that the charges are coming from magnesium being 2 plus, hydrogen being 1 plus, and then the total negative charges coming from PO4 being minus 3. Therefore, it must be B, because only that has correctly balanced charges within the compound. So, the answer to question 11 is option D. There's multiple different methods to find this answer. However, the one that I'm going to explain and is shown in the working below. So, first you've got to work out 75% of 480 kilograms, which works out as 360 kilograms. From this, you've got to find that 1 mole of lead sulfide is 239 grams. We're going to work this out as an approximate using 240 grams. This is going to make it a little bit easier, as remember you won't have a calculator. So, from this we've got to work out the number of moles of lead sulfide. From this you've got to do 360,000 grams of the ore divided by 240 grams, which is 1 mole, to find that the number of moles of lead is going to be 3/2 times 10 to the 3. From this you've got to use the equation mass equals the moles times the MR, which is ultimately going to lead you to 310.5 kilograms. The only one of the options which is close to this estimate is 311.8 kilograms, which is the option D. The answer to question 12 is the option C. To work this out, you must realise the structure of the periodic table. So, we know that the group shows the number of electrons in the outer shell of the atom, and that the period shows the total number of shells of the atom. In this example, Y has gained a -3 charge. This means that 3 electrons have been added to the atom. The atom, Y, must then therefore have the electrode configuration 2, 8, 5. This means that Y is in group 15 and period 3, as it has 5 electrons in its outer shell, as well as 3 shells in total. So, we've already looked at some practice questions today. The best practice questions you can do are on the past papers on the BMAT website, but you could also look online and in books. But paying extra isn't necessary, as the official BMAT site has lots of resources. But if you ever did want to do more, look at reviews and try and find any second-hand books, or from school or friends, as well as family, as well as browsing online to keep your costs low. Also, remember, if any skills you need help with, you could ask teachers at school, or also look online at things like forums. I'd like to thank everybody for listening, and I hope that I've helped. I have linked some resources discussed in this session, and remember to look for more for yourselves which might suit your revision best. If you have any questions at all or want more information,